Hello students, today we have to discuss the mathematics of finance lesson. These are the learning objectives. At the end of this session, you should be able to explain the concept of time value of money, calculate and compare simple interest and the compound interest and explain their formulas and apply them to various financial scenarios and calculate the present value, future value and present value under a lump sum, annuity, perpetuity using the discounting formula. Okay, let's move on. First of all, let's have a look on the concept so-called what is time value of money. So time value of money means rupee today is more worth than the rupee to be received on future, right? On tomorrow or else. The rupee today is more worth than the rupee to be received on tomorrow, right? Therefore, the idea is that today's specific sum of money is worth more than the same amount in the future because time allows us the opportunity to postpone consumption and earn a return. That means when your parents' time, if they have rupees 1,000 in their hand, they are very lucky enough, right? They can even buy more of the goods, right? For that 1,000 amount. But when it's come to today, right? It's a joke, right? If you have the rupees 1,000 on your hand, you can afford or you can buy only very few things, right? Likewise, so why that? Because of the time value of money, right? People don't care today 1,000 rupee, right? But when it's come to our good old days, 1,000 is a very valuable amount of money, right? Right. So why it is important to learn the time value of money concept, right? These are the significances of time value of money, right? In order to avoid the inflationary effect on assets. That's why the banks are allowing us to pay an interest, right? When we are obtaining a loan from a particular bank, the bank always ask us to pay a kind of an interest, right? So that's why, because of this inflationary effect, right? To secure the assets return both in the short and the long run by creating proper working capital management, right? And capital budgeting decisions, right? Capital budgeting decisions. So here actually, what do you mean by the working capital? It's the measure of a company's short-term financial health and operational efficiency, right? Working capital we can calculate by taking the current assets of a particular company and minus the current liabilities, right? Current assets and the current liabilities. So that is the thing. So what do you mean by current assets? Current assets means the assets that can be converted into cash within only 1 year, right? Within only 1 year. Current liabilities means they are very short-term debts and obligations due within 1 year. Always a time gap is kind of a 1 year. That means a short term, right? So you have to take the difference between that. That is a working capital. It's a measure of working capital is a measure of a company's short term financial health and operational efficiency, right? So capital budgeting decisions means when a company, suppose an example, when a company is in a decision to purchase a new equipment to kind of a new equipment in order to smooth the run of their operations. So kind of a capital budgeting decisions, right? It's not a daily transaction or daily operation, right? Because companies are not buying all of the goods, right? All of the goods in the sense means all of the capital or the fixed assets daily. They won't buy, right? They won't buy capital assets daily, no? Therefore, capital budgeting decisions is very important decisions when it comes to the fixed assets, right? Okay, right. So in order to calculate the cost of capital, right, to calculate the cost of capital when a firm is going to raise capital and to determine the pricing of bond insurance, right, and to find out whether lease financing is applicable or not. So these are the significance or importance of time value of money, right? So what do you mean by here the bond? Bond is a kind of a type of a security, right? Where you, the investor, are essentially lending money to the borrower, such as a government or a corporation, right? Likewise. Okay, let's move forward. Right. Let's have a look on what is meant by the simple versus compound interest rate, right? So simple interest means from the name itself you can identify interest is applicable only on which the principal amount, right? Compound interest means interest is applicable on both the principal amount and cumulative interest term. So what is the difference between simple and the compound interest rate? In simple interest, interest rate is applicable only for the principal amount, but when it's come to the compound interest rate, interest is applicable on both the principal amount and the cumulative interest earned, right? Let's have an example. Suppose you have rupees 1,000 in your hand, right? Suppose like this, you are taking kind of an amount from a bank or any other financial institution. The amount is rupees 10,000. The interest rate applicable for this particular amount is 10%. This is the question. So the question is asking you to calculate the simple interest, right? Secondly, it asks you to calculate the compound interest, right? So what is a simple interest in this scenario? Take your principal amount, apply the relevant interest rate for that. So what is a simple interest then? Only 1,000. When it's come to the compound interest rate, so here you can actually have a look on that. In simple interest rates only interest is applicable only on the principal amount. Therefore, 10,000 is our principal amount. We just apply the relevant interest rate for that particular 10,000. Therefore, what would be the interest in simple interest? 10,000, right? 1,000, 1,000. When it's come to the compound interest, here the first year, suppose like this, compound interest for 2 years, right? The question is compound interest for 2 years, right? Suppose like this. Therefore, the first interest is, first year interest rate is 10,000, sorry, the 1,000. Here the year one. Suppose the question has been asked you to calculate the compound interest for 2 years. For 2 years. Therefore, in first year, what is our interest rate? Same as the simple interest calculation, right? 10,000 multiplied by 10% because that's the principal amount, right? Therefore, what would be the relevant interest compound? I mean, the interest in particular 1 year, only 1,000. When it's come to the second year, we know that compound interest rate means interest is applicable on the principal amount and the cumulative interest earned as well. Therefore, you can see the previous year interest is 1,000. Therefore, the initial or the principal amount is 10,000, right? Plus this 1,000. Therefore, what is our total amount? 11,000. For this 11,000, apply the relevant rate. What would be the relevant interest there for particular 2 year? It's 1,100. This is the interest rate for 2 years. Clear? Right? Have a look on that. Okay. So that is how you have to calculate. Why? Because in compound interest, always the cumulative interest earn composition is there. In the first year, there is no any cumulative interest earned because we are in the first year. Right? Therefore, the interest calculation is same as the simple interest, but this is a compound interest. Therefore, you can take 1 year, I mean the first year, our interest is 1,000. But when it's come to the second year, there is a principal amount and now we have the cumulative interest earning and in 1 year, right? In the first year, previous year. Therefore, we have to add that to the principal amount, 10,000 plus 1,000. You can add them together, then you can get 11,000. For this 11,000, what you have to do, you have to apply the relevant interest rate as 10%. Then you can take the interest as 1,100. So that is the compound interest in first year. It's 1,000, but when it's come to the second year, it's 1,100. When it's come to the third year, what you have to do? Take the principal amount and apply the relevant interest rate, right? Likewise. Okay. Okay. Apply it and see, obtain what would be the value you get. So here actually in this first year, even though the interest is 1,000, you can actually the 1,000, you can calculate the principal amount at the end of the first year as well, like this. You only calculate the interest rate. Suppose 1,000 is there, 10% is of annual the interest rate. Therefore, compound interest in 1 year, our interest is how much? 1,000, 10%, 100 is our interest rate, right? So principal at the end of first year, what is our principal then? Yes, 1,000 plus this 100. Therefore, what would be the total uh, the amount in the beginning of the second year? It's it's how much? 1,100, right? So is this the interest rate? No, this is not the interest rate. 100 is relevant interest rate for 1 year, the first year. In second year, is it 100? No, no. What is the relevant interest rate? Principal amount. Yes, principal amount plus the interest earned. This is the principal total amount, right? Total amount. The relevant interest rate is 10%, 110. This is the relevant interest in second year. But when it's come to the principal amount at the end of second year, you have to add the amount 1,100 plus 110. Therefore, what would be the amount? 1,210. Likewise, when it's come to the third year, what would be the relevant interest? Take the relevant total amount 1,000 uh, 1,210 multiplied by 10%, right? What is the answer? 121. This is the relevant interest, right? Interest, compound interest. When we calculate the principal at the end of third year, what would be the principal amount then? It's about 1,210 plus this interest rate, right? Then you can take 1,331, right? 1,331. This is the principal amount at the end of third year. Clear? like this. Clear? Okay, have a look on for a while whether you could understand to do not understand or not. Right? This is how you have to calculate. Therefore, don't confuse with the amount. The circled one, I mean the square, the quad one are the interest, right? These are the interest. First year, 100. Second year, 110. Third year, 121. These are the interest, and relevant principal amount at the end of each consecutive year is principal amount at the end of first year, 1,000 and 100. When it's come to the second year, at the end of principal, at the end of second year, it's 1,210. And at the end of third year, the principal amount would be 1,331. Simple like this, right? But in simple interest rate, there is no any compounding, the cumulative interest rate as that. This, right? Okay. So here, when it's come to the same amount at the simple interest, what would be the simple interest at the end? After, for 3 years, Q likewise. Here, 1,000, 10%, 3 years. No? There is no any cumulative. What would be the relevant amount? 300. Right, but when it's come to the second, the third consecutive year in compound interest, you can see it's higher, right? It's actually, yes, 331 rupee. It's the interest rate, right? So here there is no any cumulative simple interest in 1 year. What would be the amount? 1,000 multiplied by 10%. Second year, 1,000 multiplied by 10%. Third year, 1,000 multiplied by 10%. The same amount, therefore, rather than putting them again and again, what I did was take the principal amount, multiply the relevant interest, and multiply the relevant years, right? Then we can obtain the amount by one, right? By once. Okay. Right. So these are the relevant formulas, right? Look on that. Simple interest. Simple interest is the amount that is calculated on the basic amount or the principal amount borrowed for the entire period at a particular interest rate, right? The interest rate is given in the question. It grows linearly and is preferred for short-term loans as well. Simple interest is given by the formula like this: the principal amount multiplied by the rate of interest multiplied by the time period, right? Then you can divide by 100. Okay, it's like this. There is no any newness in here. Suppose like this, 1,000, 10, rather than putting the percentage sign, you obtain like this and divide by 100. You can get actually same amount, right? 3,000. But if I apply the 10% over here and multiply by 3, what would be the amount? The same amount, right? All are same. You can get this relevant formula, right? This one, right? Use this formula. P multiplied by R multiplied by T divide by 100. The whole divide by 100. Not only T, not only R, not only P. All of things, all of the amount you have to divide by 100, right? Then what would be the amount obtained after calculating the simple interest? Then what we have to do? Principal amount equal principal amount plus the simple interest, right? Therefore, A indicates the amount, right? Since amount means A is a starting letter. That's why here A. R is the principal percentage rate of interest. T is the time duration. P is the principal amount, and SI means the simple interest, right? Okay. Compound interest. Now you know how to calculate the compound interest in various scenarios, right? The interest in which the interest of previous years is added to the principal amount for the calculation of the compound interest. The compound interest grows exponentially, and this is very powerful for long-term growth. When it comes to the short-term growth, it's preferable for the simple interest. But when it's come to the long-term growth, compound interest is there. As it increases the cost of borrowing over time, which can lead to higher interest or higher returns compared to simple interest. You obtain the result, right? You obtain the result in previous question. Actually, the example can, if you can remember, in the simple interest we earned actually 300, but when it's come to the compound interest, you obtain the interest as 331, right? Therefore you can see it's lead to the higher interest, right? Interest or higher returns compared to the simple interest. In simple interest it's only 300, but when it's come to the compound interest case, 331 rupee, right? Likewise, therefore look on the formula. You have to take A. A means the total amount of money after compounding. Yes, the amount. P means the principal amount or the initial amount. Then what you have to do, you have to multiply by 1. 1 is fixed. Always it's 1 fixed. You can't change 1. 1 is there. 1 is the definite one. The 1 is fixed. Plus default. 1 is default. Plus R here, the rate of interest, divide by N. Divide by N. N means to represent the number of times interest rate compounded in a year. Suppose the interest rate is compounded annually, then no issue. If it is compounded monthly, what you have to do, you have to divide by how much? You have to divide by M, 12 monthly, if it is monthly. If it is daily, you have to divide by 365, right? If it is semi-annually, you have to divide by what? 2, likewise, right? Then T represent the number of years, right? Number of years, right? Then when it's come to the, when N is a quarter, you have to divide by 4, right? And in that particular sense, if it is a quarter by case, you have to divide by 4, right? Because quarter means 3 months. How many quarters in particular 1 year? It's 4, right? Okay, right. Let's have a look on the present value and the future value, right? Okay, the present value means from the name itself, it's very easily you can recognize it's a current amount, right? For future amount of money, the current value of a future amount of money. Suppose you will be receiving 10,000 in uh, 2028, then what would be the current value means you have to take the current value of that particular future amount of money, likewise. Or it can be a series of payments evaluated at a given interest rate, right? Future value means what would be the future value of a present amount of money. Same as that, a series of payments calculated at a given interest rate, right? Okay. Look on the example here. The future value in 2 years of $1,000 earning 5% annually is an example of computing the future value of a lump sum here, right? Actually, we can solve this question by using 3 methods, right? First one, I'm pretty sure you will be having the program calculator or a scientific calculator, right? To solving the math. You can actually solve this question by using the mathematical equation. Within a shorter period, I will show that kind of a for equation. And then using financial math tables also, you can actually get this value. If it is a financial math table, we will be provided, right? Right. This is the relevant equation for future value. Always, future value is equal to the present value multiplied by 1 plus I power of n. Here always, because you are calculating the future value for present amount of money, right? If it is a future value, right? Since we are in the future value, okay? Right. So take the present value multiplied by here 1 is default, I is there, and you have to take the power of n, right? In this question, the future value in 2 years, what would be the future value in 2 years? How many years? 2 years of rupees, the $1,000, right? Okay. Then here the 1,000 means what? It is your present value. What would be the present value of $1,000 in 2 years? Likewise, right? Here you can see one is fixed. I means 0.05. Right? 0.05. Power of here in means 2. Why? Because it's mentioned as 2 years, right? Take your calculator and obtain the value first. uh, the press 1 plus 0.05, then press the equation sign, then you can get 1 point, uh, 1.05. 1.05. Take the power button, right? 1.05. You can see in your calculator there is a symbol called like this. Press it, right? This one. Press it, then press 2. Then press 2, then you can obtain some value, then keep it is press 1,000. Press 1,000. Answer is there. Ans. Press 1,000. Then you can obtain the value as $1,000. The 1,102.50 cents. Right? 50. 1,102.50 as the dollars. Right? Right. Okay. We discuss about the future value, right? The opposite of that is the current value. That means our present value, right? Okay, have a look on here. How much do you need to invest today if you want to make a single payment of $30,000 in 18 years if the interest rate is 8% here? The compounding period is not given, therefore, you have to have the knowledge to identify here 8% is the annual interest rate, right? This is an example of a kind of a lump sum here. Lump sum means a very cumulative amount, right? Lump sum. Okay. So here again, read the question. How much do you need to invest today? The question is asking you to calculate the today value. That means the present value, right? So we know, look on here, we know FV equal PV 1 plus I power of M, right? Here we have to find the present value. Therefore, we can customize the same equation. We have to isolate PV. We had to isolate PV, and therefore we have to divide the opposite of the multiplication. Here the multiplication, right? Even though the multiplication is not there, you have to have the awareness. Here the multiplication, the opposite of multiplication is the division. We have to isolate PV. Therefore, the opposite math we have to use. Mathematical operation we have to use here, cut it off, the remaining is PV. Therefore, what would be the present value formula? PV equal PV equal PV equal FV divided by 1 plus I power of n, right? Same. I mean, in case if you just forget the relevant formula, it's okay. But if you have the memory on the future value formula, if you know the future value formula, you can customize the future value formula to find out the present value. That's it, right? Okay. So here, let's substitute the relevant values. We know here 30,000 means our um, the future value, right? And 18 is our n, right? 18 is our m. That means, 18 is our n. And 18 is our n, and then here 8 is our r, right? Therefore, 30,000 is our the future value divided by 1 plus 8%. N is our 18, the number of years, right? Obtain the value as, use your calculator and obtain the value, right? First, 1 plus 0.08, right? Add the press equation, then you can get 1.08. Then keep it is and press the power button, right? Power button hat sign, right? And then press 18, then you can obtain the value. Keep it is and press 30,000 and then divide by the ans. Ans means the answer. Answer in the sense means 1 plus 0.08 power of 18, right? Then you can get the 7,507.47 dollars, right? Okay. Or else you can use a calculator as this 30,000, press 30,000, divide, open a bracket, right? Again, open a bracket. There are two brackets, 1 plus 0.08, right? Close the bracket and press the head button and 18 and then again close the bracket, right? Okay, right? This is the answer. Calculate and obtain the value whether the answer is correct or not. 30,000 divide by 2 brackets 1 plus 0.8 power of, use the head button. You can obtain easily the same amount, right? Okay, right. Up to now, what we discuss is, coming to the front, what is meant by the time value of money and then why it is needed for us, right? And then what is the the differentiation or the differences between the simple and the compound interest rate. In simple interest is applicable only on the principal amount, but in the compound rate case, interest is applicable on both the principal amount and the cumulative interest earned, right? And then we obtain actually, we did the relevant example as well, and simple interest formula we know now, and the compound interest. And then we recently discussed about the present value and the future value with equations, right? And then now we have to discuss about the annuities, right? Okay, so in the annuity case, actually, two or more periodic payments, right? All payments are equal in size is equal with respect to the payments, right? I mean, all payments are equal in size, equal size payments, right? Then periods between each payment are equal in what? Length, right? Okay, right. There are actually two types of annuities, right? Ordinary annuity, that means the payments or receipts are being paid or received at the end of each year, each month, each week, whatever the each period. But when it's come to the annuity due, payments or receipts occur or paid or received at the beginning of each year, each month, each week, right? Each period, annuity due. But with the perpetual annuities also, we can take three types of annuities as well, but mainly two types. Here, ordinary annuity and annuity due. When it's come to the perpetual annuity, it is expected to be continued forever. There is no any closing period. It's continued forever, right? Okay. Right. Look on the example, future value of an ordinary annuity. Right? There is an example which is given as a sum. Suppose you plan to deposit 1,000 annually into an account. Each and every key terms has a meaning. At the end of each of the next 5 years, here the hint is there at the end, right? But by looking just as the end or beginning, we can't decide where it's a ordinary and a annuity due. We have to read the question carefully. If the account pays 12% annually, what is the value of the account at the end of 5 years? So you can see actually here 1,000 is being deposited at the end of each of the next 5 years. At the end of each of the next 5 years means you can see a kind of accumulation, right? Therefore, it's kind of a, the lump sum, right? At the end of 5 years, what would be the relevant amount? That is what the question is asking, right? So here clearly it has been mentioned at the end of 5 years, what would be the value? Therefore, is it a present value asking? No, it's the future value of a annuity. Which kind of annuity? It's an ordinary annuity. Why? Because the payment, right? Here the deposit, the receipts are being actually uh, you have been deposited 1,000 in each and every uh, 5 years, right? What would be the value of the account at the end of 5 years? That is what the question is asking. Therefore, you can see here 1,000 is deposited in each and every year at the end, right? At the end means kind of an ordinary annuity, right? Since the question is asking us to calculate what is the value of the account at the end of 5 years, definitely it won't be a present value, rather a future value, right? In the same question, we can solve by using a program calculator and using a mathematical equation and using a financial math tables, right? We are using the mathematical equation, right? So here, carefully look on future value of an ordinary annuity. The formula would be like this. A, that means the initial amount or just the amount, multiplied by 1 plus I power of n minus 1 divided by I. The whole divided by I, right? Here A amount multiplied by, open a bracket, 1 plus, right? 1 plus I n minus 1 divided by I. Here division is allowed for 1 plus I power of n minus 1 whole part, not A, right? You have to use the brackets for the separation, right? Right. So this is the formula for what? Future value of an ordinary annuity. Ordinary annuity, right? Okay. When it's come to the annuity due, only remaining thing is, the only new term would be 1 plus I would be added to these formulas. That's it. Nothing new, right? Let's have a look. This is the relevant formula. Therefore, look on this question. Suppose you plan to deposit 1,000. 12% is our annual interest rate and 5%. Therefore, we can substitute here. A means our 1,000. Here, 1 is default plus I means 0.12 or else 12%, whatever the thing. Right? Open a bracket and close a bracket. This 5% is applicable. So this 5 as the power applicable for these two terms, right? 1 and the 12%. Right? Minus 1, it's fixed. It won't change with the question to question. Divided by I means our 12%. So, but in this question, there is no any, the hint for whether it's the annual interest, the 12% is just the annually, right? It's not the monthly applicable. It's not the, the quarter like, but if it is there, we have to adjust our I and our N accordingly. Our I and N accordingly. If it is monthly, what you have to do? Divide I by M. Here N, you have to multiply it by M. Here I. Whatever the I is there, you have to divide by M. Whatever N is there, you have to multiply it by M. Right? If the 12% is monthly, suppose like this, therefore your M is how much? It's 12. Here again, M is 12, right? Here also 12. Likewise, right? Compounding period, you have to be adjusted. Therefore, you can be customized this relevant formula if the compounding is applicable, right? Okay. In this question, there are no. Right. Take your calculator. Press with me. Press the numbers with me. Operations. Do the command operations with me. 1 plus 0.12, right? What would be the value? 1.12. Take here, press your head sign or the power sign, and then type 5. Then you can take the amount as, I'm using the calculation for this part, right? I didn't type this 1000 yet. Therefore, what I did was 1 plus 0.12, right? Press the summation button, equation equal sign, and then you can get 1.12. Then keep here, right? Keep it is as this, and then type power sign, the head sign, and then type 5. Then you can obtain the value as 1.7623416832. From that amount minus 1, then you can get 0.7623416832. From the whole amount, you have to divide by interest. That means annual interest rate for in this question, 0.12. Therefore, what would be the value for this particular thing? 6 point. Look on the steps, right? I'm teaching you with the steps. Follow the relevant steps as it is. What I did was, I'm first using, I'm trying to solve this part, right? Then you can get the value as, for this, the circle one, your value should be 6.35284736. All are not needed. You can take this 4 digits, right? 4 digits. 6.3528436. Right? Then this whole amount just multiply by 1000. Right? Then what would be the relevant value? If you use only 4 digits starting from 1 and the other, I mean, the other 3 decimals. Therefore, the answer would be $6,352.85, $0.85, right? Likewise, it's very easy. Right. Then the opposite of that, present value of an ordinary annuity, right? We are still in the ordinary annuity, so you can see here for a while. Future value case, what we did was a multiplied by 1 plus I power of n minus 1 divided by the whole by I. But when it's come to the present value, there is some kind of, the arrangement is there here, even though the second second term is minus 1, when it's come to the present value, it come to the front. 1 minus 1 plus I, you can see the exponent has become a negative 1 with the negative sign, right? Minus n divided by I. Therefore, what would be the present value of an ordinary annuity formula? A multiplied by 1 minus 1 plus I power of minus n divide the whole by I. When it's come to the future value, there is no any negative signs in the equation, just a multiplied by 1 plus I power of n minus 1, the whole divided by I. That is the thing. But when it's come to the present value, you can see the orders are quite changing. Minus 1 come to the first as 1 minus, and then positive n in the future value case, it becomes a negative in present value of an ordinary annuity. This is the formula. This is the formula. Right. Let's have a look on the nominal versus effective interest rate as well. Right? So in the nominal interest rate, you can see just the contracted or stipulated interest rate for a year, which is not adjusted for frequency of compounding. There is no any adjustments for a frequency of compounding. But when it's come to the effective annual interest rate, the rate of interest for a year, which is adjusted for the frequency of compounding. Therefore, frequency of compounding is not in the nominal interest rate, but in the effective annual interest rate. When it's come to the EAI formula, 1 plus R divided by M, right? M means only R, right? And M minus 1. 1 plus R divided by M. Sorry, my cursor is not fixed. 1 R this is the relevant formula. 1 plus R divided by M power of M minus 1. Right? Here the division is not applicable for whole, only R, right? 1 is default, fix. It's not changed with the question to question. Therefore, if the compounding is monthly, right, the annual interest rate is 12%. Therefore, we have to do what would be, in this case, what would be the effective annual interest rate? Calculate the answer with the formula. 1 plus, here R would be 12%. I am using 0.12 over M is the frequency of compounding here. We have to compound. We have to do the compounding for monthly. Therefore, divide by 12 over M would be 12 minus 1. That is how you have to find the effective annual interest rate. If it is the 12% is the interest rate, but the compounding should be done with quarter, then your M is 4. M is 4, right? When it is daily, your M would be 365, right? Not 4, 365, right? Okay. Likewise, right? Therefore, here R is there in the interest rate. Just the interest rate. R is the interest rate. Here M is the frequency of compounding. Clear? Okay. If it is semi-annual, how many semi-annuals in a particular year? It's 2, right? 6-month period are 2. Okay. Right. We discuss about the future value and the present value of an ordinary annuity, right? Now we have a look on the annuity due, right? For that, let's have a look on the future value. Here, look, future value of an ordinary annuity. What would be the formula? A multiplied by 1 plus I power of n minus 1 divided by I. The same thing is there, but with the new one, so-called 1 plus I. Right? You can see the same formula. Therefore, future value of an annuity due means what? The payments or the receipts are occurred in the beginning, at the beginning of each year, each month, or each period, right? Just it. Therefore, if you are forgetting the relevant formula for the future value of an annuity due, it's fine if you have the memory on the future value of an ordinary annuity, right? If you have it, just have a look on that, just have a store, just have a the memory on that the new thing has been added as 1 plus I in the annuity due, not in the ordinary annuity. Therefore, as mentioned, an annuity due differs from an ordinary annuity in that the annuity dues payments are made at the beginning rather than the end, but in end is applicable for ordinary annuity. Therefore, formula would be like this. Okay. Present value of an ordinary annuity. If you can remember the present value of an ordinary annuity, the opposite of I told you the range has been, the order has been again rearranged, right? The order has been again arranged, right? 1 minus 1 plus I minus power of n. Here not minus, it's a negative n, right? The exponent become a negative 1 divided by I. The same thing. Right? 1 minus 1 plus I power of negative exponent over I multiplied by 1 plus I, right? Okay, right. Then have a look on the don't worry, we will be having the sums. Perpetuity meaning finance. Perpetuity meaning finance, right? A perpetuity is an investment asset that pays a stated return for an finite amount of time. No, it's infinite amount of time. It's forever. An annuity with no termination, there is an example of a perpetuity. A perpetuity is a type of annuity that lasts forever. There is no infinite value, right? It's infinite. The stream of cash flows does not have an end date. There is no particular end date. We can't rectify, we can't stipulate this is the end date, right? As 18 as 20. We calculate the relevant interest by using the below formula, right? PMT here, that means the payment, right? In this case, it may be the return, right? PMT divided by present value. So here, what would be the payment or the receipt here? Just the return. It's $100. Present value, how much? It is 1,000. Therefore, by dividing those two, you can obtain 10%, which is as the interest rate or the rate of return for this particular question. Okay. Okay. Then have a look on the next one. Another investment is there that pays $90 at the end of each year forever. If 10% is the relevant interest rate, what is the value of this investment to you today? Here it's asked about the present value of a perpetuity, right? What would be the today value? That is what this question is asking from you. Right here, we need to solve for the present value of the perpetuity. So, in the previous one, when it's come to the interest rate calculation, what we did was we just obtained the return, I mean the PMT, the payment divided by present value. When it's come to the present value, use the cross multiplication here, right? Present value equal PMT divided by I. Here, present value equal PMT divided by I, right? What would be the here PMT? It's 90, right? It's 90 that pays you 90 payment. And what would be the I here? It's 0.1 or else the 10%. Then we can obtain the present value as 900, right? This is the relevant present value. It's very easy, right? Okay. So this is what we have to discuss by today. First, we obtain the knowledge with respect to the time value of money, and then why it is needed for us. Then we obtain the knowledge with respect to the simple interest and the compound interest. We just did the comparison as well in the simple interest. Always interest rate is applicable for the principal amount, but when it's come to the compound interest rate, the interest is applicable on both the principal amount and the cumulative interest earned, right? And cumulative interest earned. Then we uh, obtain the relevant knowledge with respect to the formulas, right? In the simple interest and compound interest, and then we have a look on the present value and future value, right? And as a lump sum, how do we have to calculate, right? And then annuities, we did the annuity formulas as well, right? The relevant questions, and most importantly, in the nominal and the effective annual interest rate, right? And then perpetuity, we did it, right? So as a summary, I have been amended some kind of questions for your perusal. Let's have a look on them one by one. Mr. Tulshan wants to make an investment of rupees 500,000 for 6 years. He has two alternatives. First alternative provides him a return of 8% compounded annually. Compounding period is there, but it's annually. And the second alternative provides him a return of 7.5% compounded semi-annually. On here, look on compounded semi-annually, right? Which alternative should he select? That is the first question. The second one, how much must you deposit at the end of each of year in an account that pays an annual interest rate of 12.5% if at the end of 5 years you own 100,000 in your account, in the account, right? Third one, a bank offers you a loan of rupees 1 million at an interest rate of 12% for a period of 5 years. What would be the value of an installment if installments are paid at the beginning of each month, not each year? right? Compounding period adjustment should be there. Mr. Silva is planning ahead for his son's education. He is 10 now and will start university education in 10 years, right? How much will they have to set aside at the end of each year to have rupees 650,000 in 10 years if the annual interest rate is 7%, right? Final one. A life insurance company has offered a person a new policy that will fully paid up when he returns 50. At that time, it will have a cash surrender value of rupees 180,000 when he returns 70. The policy will have a cash surrender value of rupees 377,280. What annual rate of interest is the insurance company promising on his investment, right? These are the questions to be referred. Let's have a look on them one by one then. Right. The first question, Mr. Tulshan wants to make an investment of rupees 500,000 for 6 years, right? He has two alternatives. First alternative provides him a return of 8% compounded annually, and second alternative provides him a return of 7.5% compounded semi-annually, right? Which alternative should he select? This is the question in answering, right? Okay. So here by looking at this, you can see this 500,000 is the today value or the present value, right? What we have to do is we have to calculate the future value in order to select which option suits him, right? Which option choose him. Likewise, right? Or else the which option, which alternative is better enough for him, right? Okay. In the first alternative here, what we have to do, we have to compare the future value with respect to the present value, right? How much we can obtain, we can get in future. In future means after 6 years, we can obtain the amount. Therefore, we have to do the comparison, right? Okay. The first alternative, have a look on that. 8% compounded annually. Okay. Then the future value we have to compare in both alternatives, and then we can make a decision by looking at the future value, right? Which is the highest future value? We can go with that, right? Okay. So the present value formula, write it. Present value equal the present value uh, multiplied by 1 plus I power of n, that is our future value, right? Always we have to calculate the relevant stuff to the present value only when we have to find the future value, right? Here, future value, right? When you are writing down some kind of, the answers, first of all, write it. What is the present value? In this question, first write the formula and then after that, following that formula, you can write it down the substitutions, right? The present value is rupees 500,000. Then it's very easy for you to write down the answer. Okay. 500,000. And then what would be the N here? It's 8% annually, compounded annually. What would be the T here or the N? So here N would be how much? It's 6 years. 6 years. What is our I or else our R? It's our 8% compounding period, but it's annually, right? Here N or T, whatever the thing, but normally we are using N, right? Right. These are the things, then we can amend the relevant substitutions for the formula, right? Present value, 500,000, open a bracket, 1 is default plus, I means 0.08. That means the 8%, right? 8 divided by 100, then you can obtain 0.08, right? So here, what would be our N? It's 6, right? Take your calculator and press 1 plus 0.08, then you can obtain 1.08. Then keep it and press the hat sign or the power sign there, power sign, and then 6, right? Then keep the answer as it is and then multiply it by, press multiplication and press 500,000. Then you can obtain the value as 793,470, 436, 37.16, right? 16 cents actually. Okay. The second alternative, right? The second alternative, I told you, if it is monthly, our N would be it's 12. If it is daily, our N would be 365. If it is semi-annually, our N would be, is it 6? No, no, no. It is what? It is our what? It is 2, right? How many semi-annual periods for a year? It's 2, right? Okay. So in this question, we have to make some kind of amendments for the main equation like this. Compounding is there, right? Multiplied by m. I told you, right? I should be divided by m and n should be multiplied by m, right? Present value is 500,000. One is default plus here I would be what? 7.5 means if you just divide by 100, you can obtain the value as 0.075. What would be our n? Is it remain as this? No, because compounded semi-annually is there. Therefore, we have to divide by 2. That is what this, the second passage is, has actually completed, right? Divide by 2. And then here, what is our n? How 12 came? Our n would be initially 6, right? 6 years multiplied by here, what would be our n? Even though 6 years, that the rate has been compounded semi-annually. For 6 years, how many semi-annual periods? 12 multiplied by 2. That is how this 12 came, right? And then you can obtain the value as, clear, you can obtain the value as this much, right? Take the calculator and type 0.075 divided by 2 at 1. For that particular thing, keep it and press hat sign, right? The power sign, and then type 12. Then equal. Then the answer, keep it is and type 500,000. I mean, press 500,000 and then you can obtain 777,727.17 cents. 70.70, right? Or else 777,727 and 17 cents, right? Therefore, you can see which option is having the highest future value. Is it second one? No, the first alternative. Therefore, first option should be selected. It gives the highest amount, highest future value after 6 years of investment. Clear? This is how you have to calculate the answer. First of all, write the formula and then do the substitution. What is PV? What is FV? What is N? What is I? Likewise. Then the possibility to get the correct answer is 100% equal. Right? Okay. Right. Look on the second one. How much must you deposit at the end of each year in an account that pays an annual interest rate of 12.5% if at the end of 5 years you want 100,000 in the account? So it's kind of a very easy thing. What is it? It's the, yes, future value of ordinary annuity, kind of a future value of lump sum, right? Lump sum. But when it's come to this question here, the end of 5 years, we want 100,000 means, end means, ordinary annuity thing, right? End of 5 years, if we want 100,000 means, of course, it's definitely a kind of a future value. Therefore, we can amend the future value of ordinary annuity formula for this question, right? Same thing, future value of ordinary annuity, how do we have to calculate the value as a multiplied by 1 plus I power of n minus 1. Clear? Divide 1 plus I n minus 1 term only by I. Right? Okay. So what would be the future value of ordinary annuity? We know 100,000 only. Take the 100,000 here. If it is the value, if it is value 100,000, what would be our A? That is what the question is asking, right? How much you deposit at the end of each year? That is our A amount to be deposited at the end of each year or 5 years, right? Okay, A is what we have to find. Okay, then write the formula and then find here FE of ordinary annuity or the future value of ordinary annuity is 100,000. A, right? A and equal the question mark. A is what we have to find, right? A we do not know. What about I? I is 12.5%. What about N? It's 5%. That's it, right? Is there any compounding adjustments? No, no, no. There is no any compounding adjustment in there, right? Then 100,000 equal to A, it's what we have to find because it's asked about how much must we deposit at the end of each year, and open a bracket 1 plus our interest rate 0.125. How it is came as this 12.5 divided by 100, right? 0.125 to the power of 5, only 5 years, right? Minus 1 divided by 0.125. Right? If it is a semi-annual or monthly or daily, we have to only need to do the adjustment as this. Whatever I is there, we have to divide by M, right? Whatever I is there, we have to do the division by M in all where we can find M. But N is there is no division, rather multiplication by M. Clear? Okay? Okay. Here, there is no any compounding adjustment, right? Take the calculator, do with me. Do with me. Press 1 plus 0.125. You can obtain 1.125. Keep it is and press hat sign. That means the power, right? 5. Then you can obtain 1.8020324707. Keep it and press minus. I mean the subtraction value and 1. Then you can obtain 0.80203247 4707, right? 0.8020324707, right? And then keep it is and divide by 0.125. Then you can obtain the value as 6.4162597656, or else you can take as the approximate value only three decimal places, right? 6.4163. Right? 4163. Because we can know if it is if the higher value is higher or same as 5, right? Normally higher than 5, we can actually add 1 to the uh, prior value, right? Before 5 value, right? It's like this. The whole thing for this particular thing part, we can get this value in 0.41625 97656. This is the whole value, right? Typically, it's no need to write down all of the decimals, right? Instead of that, what you can do is you can actually take 3 decimal places or 4 decimal places, right? You can see here 5 is there. If we take only 4 decimal places, you can see after 2, you can see 5 is there. If it is 5 or higher than that, we normally add 1 to the prior value, right? Before value. Therefore, because it's a rounding of the norm, right? Here 5 is there, so we can add 1 to here. Therefore, 6.4163 is the approximate, rather approximate, just the value, right, for this part. It's no need to write all of the lengthy term, the decimals, right? Therefore, so here, if you are taking only 3 decimal places, right? It is no need to add the 1, right? Because why? Here 2 is there. Is it lower than 5? If it is lower than 5, it's no need to add 1 to the before value, right? It's no need here to just keep it as it is. But when you are using only 2 decimal places like this, here you can see after 1, you can see 6 is there. So 6 is higher than 5. Therefore, you can add 1 to here. 1 to for this one. Therefore, 6.42. So here in this question, we are taking 4 decimal places for our perusal. It's depend on you. It's depend on you. Normally, my advice is take up to 3 decimal places or 4 decimal places, right? Then this is the relevant value. Then you can take A is there. How do we have to find this A value? Here you know the multiplication, A multiplied by 6.4163. So the opposite of multiplication is the division. In order to find this A value, we can isolate A by dividing 6.4, wait, 6.4163 from here and from left hand side and right hand side, like this. Here cut it off. It's divide 6.4163 divided by 6.4163. It's 1, right? Therefore, use the calculator. 100,000 divided by 6.4163. What would be the value? 15,585.40, or else the 30 or 31. What is the amount, right? Here 40 has been come actually. I'm using all of the lengthy decimals, right? Even though I just use 4 decimal places, I use all of the decimal places. That's why here the 40 has came. But if your answer is 15,585.31, then that would be also very correct, right? No doubt it's very correct. 31, right? Why here 1? Again, use the round up norm, right? Round up low. Okay, right? This is the relevant answer here. I'm again saying, even though it's 40 is there, the reason for this 40 cents is I'm using all the lengthy whole term, right? For this 6.4163, likewise, I'm using that even though I just use 4 decimal places. That's why here 40 is there. But if your answer is 15,585.31, then that would be very correct, right? This would be the answer. Okay. If we are using the lengthy one, the answer would be quite different with respect to the cents decimals, right? The last decimal. So, okay, right. Third one. A bank offers you a loan of rupees 1 million at an interest rate of 12% for a period of 5 years. What would be the value of an installment? What is the value of an installment if installments are being paid at the beginning of each month? Compounding is there, right? I mean, some kind of adjustment is there. Each month value is there, right? Okay, right. Write the relevant formula first of all. Here, tell me, rather than writing down the formula, first of all, writing down the formula, first of all, carefully you have to look on whether it's an ordinary annuity thing, annuity due, or just the future value or present value likewise, right? A bank offers you a loan of rupees 1 million at an interest rate of 12% for a period of 5 years, right? If installments are being paid if installments are paid at the beginning of each month, what would be the value of an installment? That is what the question is asking from you. So here 1 million offers means a bank offers a loan of rupees 1 million by now, right? Right? The bank is offering you the loan by now, the today, currently. Therefore, it would be the present value, right? So how do we have to rectify whether it's an annuity due or ordinary annuity? By using the relevant terms as hints, right? Beginning. So the installments are paid at the beginning of each month. Therefore, that would be a definitely what? a kind of a annuity due. Therefore, we can notice that this is not the future value. This is a present value, but this is not the present value of an ordinary annuity. This is the present value of annuity due. How normally bank offers you a loan means current amount, right? The relevant loan amount you have to be amended as the present value of annuity due. Right? Okay. What would be the relevant formula? Here there are two formulas, whatever the familiar formulas you can take. If you just refer relevant books, reference books, you can see instead of A, some books are noted as C, right? Some books are noted as P, M, T, whatever the value, but normally you can take A, right? If you take C also, that's fine, right? Here, present value of ordinary annuity equal, I told you, it's relevant for the present value of an ordinary annuity as well, but with the addition of 1 plus I, right? Even though it's asking about kind of a 12%, it's annual payment, right? Even though the annual term is not there, you have to have the knowledge to identify this 12% interest rate is kind of an annually, right? If it is not annually, it's being given in the question, compounding monthly likewise, right? So 12% means annual rate, but that is not needed for us. We have to amend this, the 12%, we have to convert this 12% to the month rate, right? Therefore, what would be the present value of annuity formula? A multiplied by 1 minus 1 plus I minus N divide by I multiplied by 1 plus I. Go back with the lecture note and then come here, right? Here, why I use M, I told you at the beginning of this question, wherever you can find I, you have to divide by M. Since it's a compounding, only the compounding issue is there. We have to customize our main equation as this. If there is no any compounding, it's no need to convert the relevant adjustments, right? No need to do the customization. Whatever the n is there, I told you it's not needed to divide by m, rather we have to multiply by m, right? Here, annual interest rate is given, but the question is asking at each month what we have to, in which amount we have to deposit it, like we have to deposit likewise. Therefore, that's why we do this, the customization, right? Okay. Then here, present value of ordinary, the annuity due, 1 million, right? A is what we have to find, right? At the beginning of each month, what we have to deposit, right? What we have to rather deposit, what we have to pay, right? Because bank offers us a loan, right? Banks offers us a loan. In return, we have to pay the interest, right? We have to pay the interest plus the installment, right? Interest plus the main principal amount, right? As the interest, the installment as the installment, okay? So here A is what we have to find. A multiplied by 1 minus obvious, it's default. 1 minus, open a bracket, 1 plus here, what is our I? Annual interest rate is 0.12. But what is our M? Here month value. If it is monthly, I told you the relevant annual interest rate we have to divide by 12. By 12. Close the bracket. Minus N is there. Minus N means here, N means how much? It's 5 years, right? Minus 5, but multiplied by 12. That means for a 5 year, how many months for a 5 year? 60 months. That's why, right? Divide the whole, not A, by 0.12 divide by 12. Why? Because we need the monthly the monthly interest rate multiplied by 1 plus here I is there 0.12 divide by 12, right? Why? I told you whatever the I is there, you have to do the adjustment by division of m. If there is n is there, even though it's negative, it's positive n power of n, right? You have to do the multiplication of m. Why? Because of the compounding interest. Even though the question is not saying you the compounding, but you have to have the awareness. This is the compounding interest rate, right? Compounding frequencies, they are likewise, right? This is how you have to find, okay? Then what we have to do, take the calculator and do it with me. 0.12 divide by 12. 0.12 divide by 12 means 0.01. add 1 for that, then you can obtain 1 plus 0, 1, right? 1 plus 0, 1. Then you can press the relevant power button and then type minus 60, right? 5 multiplied by 12 means 60. From that amount, keep it is an minus 1. Then you can obtain 0.4495503841, right? For this amount, keep it is and divide by 0.01. Then you can take the answer as 44.55503841. You can take only 4 digits, right? Multiplied by 1 plus 0, 0.12 divided by 2. That means 0.01, right? At to 1. And then you have to multiply that, and then you can obtain the answer as 1 million divided by, yes, this is the answer. Okay, don't worry, I will be showing the relevant stuff for your reference. Here, this part answer would be, again do it with me, 0.12 divided by 12 means 0.01, right? And then for that particular place, that particular number, you have to add 1. Then you can get 1.01, right? 1.01. Then like this. 1.01. 60. Right? Like this. Okay. 1.01 is there. Press hat sign, the power sign, minus 60. How this minus 60 came? Minus 5 multiplied by 12, right? Then you can obtain for this part answer as 0.5504, or else the long answer would be 0.5504496,159, right? This is the answer. From that answer, you have to do the subtraction. That means 1 minus 0.5504496,159. But if you use only 4 digits, it's okay. That is the answer. Then you know for this part, answer would be 0.4496 or 0.44955037341. I'm taking only 4 digits. 0.4496, right? We did it, and then the whole divide by 0.01. Then you can obtain 44.96 for this part only. That should be multiplied by 1.01. Then the answer would be for this part 45.4096, right? So A multiplication is there. You know the cross multiplication, the opposite of the maths, right? Here we have to find A, therefore we can remove this 45.4096 by do the division, right? The opposite of that multiplication is division. So do the division. Therefore, you can take actually 1 million divided by 45.4096. What would be the answer? 22.2 uh 22,000 yeah, 22,021.77. Here the answer would be came as the whole number. I mean, I'm using the whole digits, right? That's why. If you can get 22.021.78, then that would be fine. It's totally fine, right? Okay. I'm again saying if you can take only 4 digits or 3 digits, the final answer would be different. But altogether, this would be the relevant answer, right? If you are using all of the decimals, I mean the digits, of course your answer would be 22,024 point 20, right? Or as 21, right? But if you are taking only 4 digits or 3 digits, the answer would be quite different from this answer, right? Because the digits issue, right? Digits concern, right? So if you can take this answer also fine, right? If you are using all of the digits for the calculation, then your answer would be definitely like this, right? Rounding up you can take. If you prefer 22,024.2, then that would be also fine. If you can take 22,024.21, that's also fine. Points should be there, right? Okay, very easy. What you have to do is read the question and first obtain whether it's a future value or the present value, or is it an amendment for a hint for a annuity due or ordinary annuity likewise, right? That's the only thing. Okay. Yeah, that's it. And then after recognizing that, write the formula and then do the substitution. What is mean by PV of AD in this question? It's 1 million likewise. After the substitution, come to the formula and do the adjustments, right? Fourth one, Mr. Silva is planning ahead for his son's education. He's 10 now and will start university education in 10 years. How much will they have to set aside at the end of each year to have 650,000 in 10 years, rupees 650,000 in 10 years, if the annual interest rate is 7%. So here, it's very clearly mentioned 650,000 in 10 years. Is this 650,000 we have to be in our account in this kind of case after 10 years, right? Therefore, it's a future value. It's not the present value, right? Future value. Is it an ordinary annuity or annuity due? At the end of each year, they will have to set aside, therefore it's an annuity due, right? Write the formula a multiplied by 1 plus I power of n minus 1 divided by I. Here future value of ordinary annuity is 650,000 equal a is what you have to find, right? How much they will set aside to at the end of each year. Therefore, a is what you have to find. 1 is default, 1 plus I 0.07, right? There is no any compounding. What would be the n then? N it's directly given. It's 10, right? Minus 1 divided by 0.07. So take the calculator, 1 plus 0.07. You can take 1.07 and do type the press the head sign, power sign, then press 10 minus 1. Then you can 10 equal, and then you can obtain the value, and then from that value minus 1 and then divide by 0.07, right? I'm again saying the steps. Take the calculator, add 1 plus 0.07, then you can take 1.07. Type head sign, the power sign, and then type 10. Then you can take actually 1.9671513573, right? The all digits. 1.9671513573 minus 1, right? And then you can obtain 0.967, or else 0.967151353. It's no need to take all of the digits. You can take whatever you wish. And then from that amount, you have to divide by 0.07, which is your interest rate. Then you can take the value as 13.816 if I use only three digits. Or else the whole would be 13.81644796114. Here I'm using only three digits, right? Then if it is multiplied by A, that have to be taken as 650,000. In order to find A, we can obtain 650,000 divided by 13.816. Therefore, the final answer would be 47,046.90. This is what they have to set aside at the end of each year. It's very easy. Right? Okay, the final one. A life insurance company has offered a person a new policy that will be fully paid up when he turns 50. At that time, it will have a cash surrender value of rupees 180,000. When he turns 70, the policy will have a cash surrender value of rupees 377,280. What annual rate of interest is the insurance company promising on his investment? That is what the question is asking. Tell me, is it an ordinary annuity or annuity type? No, there is no any hints over there. Instead of that, there are some kind of the time frame. I mean, the time periods are there. Cash surrender value is there, right? Therefore, it's kind of a hide and seek, right? Today cash surrender value is there. After, when he turns 70, cash surrender value is there. Then therefore you have to have the knowledge. These are not the annuity due, whatever the things, just the future value, right? Therefore here, what would be your FV? This is what? After, when he turns 70, 377,280. What would be your future value? At now value, right? When he turns 50, that is the when he turns 50, this is a kind of a cash surrender value, right? So 180,000 is the present value. One is there, so I is equal to how much? I is, we do not know. I, what we have to find, right? Keep the I as it is. N would be what? So you can see 70 is the future age, and now age, I mean the current age is 50. The difference between 70 minus 50 is the time frame, 20. We can't take either 50. We can't either take 70. Instead of that, we have to take the spread of the time period as 20 in between 50 and 70, right? 20. Okay. Then you can take, here I is what we have to find, right? What we have to do, isolate I. In order to isolate I, we have to remove this 180,000 by division, right? So 377,280 divided by 180,000 means 2.096. Take the calculator, do the operation with me. 377,280 divided by 180,000. You can take 2.096 is equal to, here you know these things, 180,000. I'm dividing. Here also I'm dividing. For this part, it's divide. 80,000, cut it off. Because it's division, it's only one. Here also 8,000, 180,000. The answer would be, by division, you can take 2.096. 1 plus I power of 20 remains as the right hand side, right? Okay. So you know the thing as this. If it is the square root of 16 means, you know, 16 half, right? This is what the square root is saying you. Okay. Square root in the sense means the half value, right? When you are to find square root of 16, you maybe say 4 is the answer, right? The square root indicates the half. If the root is indicated as third, it's 1/3. Likewise, right? So here, take the calculator and use the hat sign, right? I mean 16 hat power sign, and then press half. I mean 0.5 or 1 over 2. We can obtain 2. The whatever the thing, we have to do the stuff as well. Here the power is there, right? Power is there. The 20 is the power. 20 is the power. If it is the 20, in order to remove this power of 20, we have to take the 1/20th, right? 1/20 in order to remove this. Therefore, you can remove this 20 and we can take 1 plus I only. Then you can find 2.096 power of 1 over 20 means 1 point for this answer. For this answer for this part, 1.0367 0.171 Clear? Take only 3 digits. Fine. Okay. Then is it the end? No, it is not the end. It is not the end. We have we have 1 as well, right? In order to isolate I, what we have to do is the opposite, right? Here the addition is there. Addition is there. In order to remove this one, what we have to do? -1 from both sides, both left hand side and the right hand side. So -1. Here, so -1 means it's cut it off, right? Since these are basic mathematics knowledge, therefore I won't test that kind of knowledge from this part, right? You have the knowledge on that particular thing. Therefore, see 1.037 minus 1 means obvious. The answer would be 0.037. In order to take the percentage value, we are multiplied by 100. Therefore, you can take 3.7 also fine. 3.7. That is the answer. That is the answer. Okay? Clear? This is what you have to find. Do the calculation with you. Here you can see the power is there, 20 power, right? Power of 20. In order to remove this 20 power, what we have to do? We have to take the half of that. I mean the 1 over 20, right? Okay, kind of a square root as well. I'm doing the square root right here. Power is there. The opposite of that is the square root, right? Do the square root of, but not 2, 1 over 20. That is what I did. Okay. Right? Here not the square root, but you know, like square root, right? In order to remove this exponent of 20, we have to take the half of that. That is what you have to find. Okay. With that, we can wind up the today's session. Let's meet on another session as well, right? Thank you.